Derek from Distributed DBA here. In MySQL, replication is an important feature for achieving high availability of your data. The default model of replication is asynchronous, which is easy to configure and does not incur a significant penalty to your write performance. However, it does have one significant drawback, and that is data loss. Keep watching to understand how semi-synchronous replication can help protect you against data loss. Imagine that you have the standard setup of a single source and a single replica in asynchronous replication. A scenario could arise that the source server dies before the replica gets the committed changes. In this situation, you may end up with data loss. Data loss can be considered if the application receives acknowledgement of the changes, but then those changes are lost during the failover. To overcome potential data loss, MySQL natively supports semi-synchronous replication. Semi-synchronous replication allows you to specify one or more replicas that must acknowledge receipts of data changes before the source responds to the user or the application making the changes. By doing this, you ensure that the changes persist on at least one extra MySQL server before the source accepts the changes and responds to the client. If the source dies, the changes are not lost because they exist on another replica. There is an important caveat to this, though. The source only waits for the replica to acknowledge receipt of the change rather than the changes having been applied on that replica. To explain that, let's remember that handling replication is two separate processes on the replica. The I/O thread handles receiving changes from the source and storing them in a relay log to be applied later. The SQL thread then takes those changes from the relay log and applies them on the replica. So in semi-synchronous replication, the source only has to receive acknowledgement from the replica's I/O thread, not that those changes have been applied. And this is why this is only considered semi-synchronous. This balances the risk of data loss with too much write performance impact. So the basic steps to enable semi-synchronous replication are to install the plugin, ensure that the plugin is active, and set the appropriate options at runtime. The important difference is that the name of the plugin is different depending on the role of the server that is being activated on. Also, the source has an extra option for configuring how long in milliseconds to wait for a replica to acknowledge before switching back to asynchronous replication. This is an important feature to understand. If semi-synchronous replicas go offline, the source will fall back to asynchronous mode. And this ensures that changes can proceed without blocking the client for too long if there are problems with the replicas. We've seen how MySQL's asynchronous replication has a significant risk in potential data loss. We've also seen how semi-synchronous replication can mitigate that risk and how easy it is to configure. But keep in mind that semi-synchronous replication is not without a cost in terms of write performance. So a data guardian will want to run a production impact analysis to make sure that semi-synchronous replication is right for them.